Okay, so I work from U.S. side, from Mountain View. So here, today come here is to a sub, like a teacher, he cannot come. So, Tony said, can you come since I speak a little bit of Mandarin? So he said, sure, why not? Okay, so let's get started. So there are a lot of materials here. What I was preparing is I think I'm going to go through some of them and leave about 10 minutes. I like to go over some of the samples to see how the things are done with Google's tools. Okay. Question-wise, after we finish, then I think we are so, that based on the number over here, we can have a very intermediate talk. So whenever you guys have a question, you can stop. And also, this one is the last one, so I think the time pressure is not that big. So, yeah, I gotta say that. 我有的可以说中文，大部分的话我不会说中文。当然我这边长大，就是平常的使用，我可以说这个 Vulkan 的 term 我不是在这儿学的，所以我只能用英语说。Okay, here we go. Let me see. So the topic of here today is performance 3D graphics for Android. Basically, but it's kind of just to give you guys an overview of what Vulkan look like. At a very high level, there's no bit byte, that in a computer like other sessions, you can cook up an application right away. Vulkan, yeah, it's kind of a little bit tough in that way. Okay, this is the fan slide. So the person on the left, right? Yeah, on the left. His name is Jesse. He's like a main person behind Android graphics. So on the right is the red book from Chronos. As a tradition, Chronos always published a book accompanying with any standard. So last week I asked them, do you need me to talk about the future? They said, no, we need to check whether you guys have NDA with Chronos. Let me ask, how many of you have an NDA with Chronos? 就是跟 Chronos Group 有 NDA 怎么翻译？就是 agreement, you share agreement, and whatever I talk, if I talk a future, whatever I talk, then you guys only keep this thing to yourself. You have something signed with Chronos. Well, I better not talk anything in the future. I don't know too much about the future either, so that's fine. So then I said, okay, I will go there, sell your books. Okay, the main topic today is about 5. So man said, why Vulkan? What is it? And how can I get started on Vulkan, on Android, right? And the last 2 is, hopefully the last one, after you hear the first 2, the problem already solved, right? Otherwise, I didn't do a good work, right? So the first one is a very important one, so some tips from partners we worked with in the past. Okay, so my focus will be on first 3. The fourth one, I will pick up 3 topics from it. He put a lot of things in there. Okay, so why do we start it over? So let's look at the vertical timeline, right? So look at this. Back to 1992, the first version of OpenGL released is the computing world is like this: 486. On that side is Windows 3.1. Well, Windows 3.1 in that, back to looking at the history, looking back, is a very important one. That is, to me, that is the beginning of the GUI industry on all the OSs or applications, the computing world, put it that way. So the bottom is kind of a motherboard. In those days, there's no such thing as a GPU. All you have is a VGA controller. Basically, a scan line, just a display. 30 or 40 registers for you to write and get the digital. You put in the memory display pins for the image you want to display, and then write the registers for the timings. Then you do the DA translation. That's all. Okay, looking at today's So mobile CPU today is look like this on CPU side. This is about the CPU. So CPU, now we all have multiple cores. This is the mobile, we're not talking about a desktop yet. So desktop we have even more powerful. Okay, so all of them, they all have a cache, they all have the multiple cores run at the same time, okay? And look at the power and clock speed. So with here, what we're trying to see is, mathematically, I think this one is the only formula you're gonna see in the slide. And I think comparing to 3D thing, this is the simplest one, the formula here. So what he's trying to say over here is the multi-core is helping for the power consumption. So by looking at the line over here, it's the 2.2, right? Where the frequency over here, with one core is over here, right? Somewhere here. So now it's about 1.6 watts. Looking at the dual core, so this second one, if I run the dual core at 1.1, right, somewhere here, I'm probably using about less than half of the power. So that point of here is by using multi-core, you really can save power for the system. And now we have GPUs. Right? So GPUs, you can look at the GPUs here, they have even just on this is one shared unit, how this thing is done inside the chip. Now, in any of the GPUs nowadays, it can easily get to 32. Now on desktop, it's in thousands. So you can see the computing power change in these 20 years or so. Okay, so with this happening, need the new things, need a new API to address the parallelization, to use those multi-cores. On GPU side, it's okay, it's already done. Because GPU, you have shaders, right? Shaders can all, you give to GPU, the shaders, they automatically schedule it, it runs it in parallel. So that part is taken care of. The only part that needs to be taken care of, and not the only one, really the very important one, is on CPU side, the parallelization. So how to address that? There is no silver bullet for this thing yet. So a lot of people have been trying to say, get a generic library to do this, but in the end, is said, yeah, it's kind of like we design a low-level API, give it to developers, application developers, let them decide what is the best for their application. Because only applications knows what is the best things they do. And with that, they know how to address those problems. Like simple things like a memory and a multi-processing. So that is the industry. That is what Vulkan trying to do. Now, by looking at the horizontally, though, you look in on iOS 2014, they released the Metal. Anybody writing program on iOS? Okay. So same thing, similar story on Windows. On Windows side, DX12 is also released around the same time frame. So those two OS, the two major non-open source OS, they all have their own solutions. So you can imagine, open source is not going to be left behind. So Vulkan is the answer to this. So Vulkan is used by, is mainly targeting for all OSs. That's the a simple way to put it is, yes, Vulkan, once it does its best. It's targeted for all OS. You can use it on all the 4 major OSs. But later on, there's a for use for that. Right? For Android, Vulkan is the primary rendering engine. So that's why Vulkan is here. Now let's get into Vulkan. So what is the major Vulkan features for us? We all said everybody is using these new API standard, right? So on iOS they have their own ones, and DX have their own ones. Vulkan, when it does it for everybody. So what is the main features from Vulkan is explicit. Explicit means with OpenGL, for example, if you don't use something, you don't have to set it. OpenGL engine will set default for you. Here, anything you use, you need to do it. You need to set it to something. The things you don't need it, you need to initialize by yourself. It's all belong to application. Okay. Those is not specific for Vulkan either. It applies to all these three major rendering engines, Metal and DX12. It's similar thing. So this explicit is kind of the industry standard. There's a trend we are moving toward to. So modern, we are going to see later for us, why why we call it modern. And another very important one is extensible. So this extensibility is very important, and it's kind of a traditional to Chronos. All the stacks, not only for graphics. So, like OpenGL, it all have the interface designed for extensions, so those kind of things. So now let's look at what explicit means. By looking at this graph, you can see from OpenGL, in driver is fat driver, right? The driver need to handle a lot of things. Your driver give you abstraction layers, and then context management, memory allocation. We're going to come here a lot of times here, and share GLSL compiler, and the validation error checking is the one we're also going to come back, and that is an important portion of it. Now all of this is going to push it over to here, to application world. So you really have power to do whatever you want, basically. You have the layer here is very thin. Basically, it's just one wrapper for the underneath hardware. So the rest is all yours. So you can really get every single cycle from the GPU with these explicit APIs. Oh, I should use that. So the benefit with explicit APIs is since you already know what is going to happen in your program, because the driver layer is so thin, it then do too much processing. So everything, almost everything, is in your application code. So this, definitely you know what is going to happen at which time. So that brings you predictable behavior and predictable performance. By comparison, OpenGL, it has to reach to a draw core to know, how to parallelize his things. Now we're coming down to the next one, is modern. Well, we touched it a little bit. So modern means we design for desktop and mobile across all OS. So later on, there's another foil for this. Is a big feature for this. So right now, you can, Vulkan standard, cross standard, is same for all OSs. So the only portion that is different is WSI portion of it, Windows System Interface. So how do you present? Once you get a drawer, you get the color buffer, then how do you present on the system? That portion is separate standard, but it's part. If you go to the Chronos, you will see that standard, WSI. So that portion is heavily native OS related. Whatever your OS it is, you need to use that OS mechanism. So that OS, when that OS support Vulkan, it will provide those services. Okay. So that brings a lot of good things for this. Is most of your code for Vulkan, almost close to. For the foil later foil is 99%, I think is close to that. So all of them can be directly used on all the OSs. You develop for Windows Vulkan, you can directly use for Linux Vulkan and for Android. For on iOS, there is Vulkan Vulkan VT. That company already put a layer, have a wrapper for Vulkan to run on top of iOS. They have a demo on SIGGRAPH this year. Okay. We talk next big feature for this is multi-threading. So we talked before that major thing, one of the major things Vulkan trying to address is CPU's parallel processing. This is for that. So how does this multi-threading work? Is you, for example, when you build command buffers, you can have separate threads on CPU. This we're talking about the CPU thread on CPU side, right? You can have separate thread build command buffers for that scene, and another thread build command buffers for another scene in the frame, in the same frame. Then you can let them submit the command into the command queue. So of course you need to handle the synchronization or portion of it because the multiple thread, share in the same queue. But those are kind of traditional programming stuff. Yeah, this leads to the next foil for us. That's an example over here. See here, in this example, he has the 4 thread and building different command buffers, then you submit to the same command queue. This thing over here, well, it's when you submit, it's your responsibility to provide synchronization. So these 4 do not corrupt your queue. Okay, so next big feature on here, we said why it's modern is the graphics and compute all supported in a standard. Although this talk mainly is about graphics. So, and another one is a shader IR. So shader in OpenGL have a GLSL shader. You give to OpenGL. Then it will compile at a runtime, and you will consume it over there. So you see, compile is at a runtime. But Vulkan only specify what is the shader layer's representation. It's called intermediate representation. This for then cut too deep in that one. That is the low level than GLSL shader. And it can be compiled offline. You don't have to be compiled at a runtime. So that the benefit for that is some of the games, when you compile, it takes a long time. So it can cause glitch. But with this one, you can compile it offline and directly give to Vulkan. Then this glitch can get get removed. So remember, 2007 we were trying to do a lot of debugging for those glitches. At that time, I was not working at Google. So the tool to do the how do you translate your GLSL shaders or the high-level language shaders to SPIR-V is yours. It's your application's responsibility. You can do whatever you want to just translate following the standard. That's all. Okay. So from Google, we have a tool called Shader C to help you to do this compiling translation. It supports both GLSL and high-level shader language. You don't have to use it, so you can do your own. So you apply your own optimization, all these kind of things. But major thing is nowadays the battle is in the shader. What decide whether you have the best application? Those things is in shader. Okay, so this slide over here, as I put it here, is from this one. These are from Chronos. So this talking about the pipeline, what the pipeline look like, and then how the buffers get submitted to the pipeline at which point. So this booklet is from Chronos. Before I came, I contacted them, and they sent it to me, so I bring it over here. So you guys can feel free to pick it up. It's right there on the table in the back. So I think the point is, I think if you are doing Vulkan rendering, get familiar with this kind of help when you coding your own application. So put it that way. Well, there's thing, right? Yeah. 只见树木，不见森林，是吧？如果 yeah，那个这边 this one is like a forest. So Vulkan, graphic rendering is a big subject. When you focus on something, that one is a kind of a leaf, right? Yeah, I might have said it wrong. Okay, so we're talking about the extensibility of Vulkan. Vulkan is designed in layers. So the layers is loaded by a loader, and the interface is well defined and across for all of the supported OSs. So it's up to OS just implement those interfaces for loader, and you design your layers, then it will be automatically loaded. Not automatic. Once you give to it, let him load it, it will load it. Now, what is the good for the layers and extensions? So if the layers give you good stuff is this. If you want to extend the sum of the functionality from the Vulkan, then this is the interface you use. And also for hardware vendors, you have your new hardware features is not available in standard yet. Layers and extensions are your friend. So, well, off subject talk a little bit. I think following standard is a good thing, and I think the better thing is ahead of a standard. The industry is moving is standard serving the industry, not industry create a standard. Industry is already moved. Whatever the standard in their industry is already moved ahead of that. So if you want to do something, hopefully you will really do something that wonderful is be ahead of a standard. Let your features move into the standard, not only for the technical stuff, good for, you feel the achievement for it, also for the, I think the first time get into market for some kind of thing like that. No, I know it's off from today's subject. Okay, so with those layers, so you can extend Vulkan at any time. And we will give you example for this is that by looking at one of the major use for layers right now in all the samples is, not all samples, so in some samples, is the validation layers. So we talk about, in OpenGL applications, there are a lot of validating code, your parameter, if correct or not, if not, do something. If correct, then you still check, right? Because that cycle is wasted. If your application is well behaved, those cycles are wasted. Now, what the Vulkan's development model is this. You can take out this. You're going to take out those validation things out of this Vulkan driver. It's not part of that here anymore. You take it out and put them into layers. Later on, we have big section for that. We have 7 layers right now. So we have all the validations in layers. You plug it in easily. Plug it in. We're going to show that. Then you write your application. Anything like parameters wrong or something set is wrong, image is not in the correct format, then those kind of things get caused by the Vulkan validation layers. It tells you right away. So after your application get well debugged and validated, and you're ready to deploy, this is the model you go. You just don't load the validation layers there. All the cycles you used to waste over here are used for your application. So that's what I said. You can really get every cycle of your GPU to your application. Even on CPU side is same. Okay. Why should you use this one? Oh, okay. So the common loader interface, we talk about that is one interface is used across the board. The loader interface is easier is this. It's well defined, and for all OS is the same thing. But for Android, the loader, all of these loaders are kind of a part of OS. For Android is the OS component. See, Vulkan is open standard, so that is another advantage for Vulkan. Yes, we touched this, before a little bit, a moment ago. It's open source. It's meant for all the OS to use. It provides for specifications and conformance test. Specification is for application users and also for application developers and also for the GPU developers, because here is a spec, and your developers is going to use this spec to develop applications. For GPU owners, like Qualcomm and NVIDIA, those companies, they also need to know what the expectation is to implement all the required features. They normally do more than just standard request. So the conformance test is meant to be used for the GPU owners. So once they have the GPU on the system, then they need to pass the conformance test. The conformance test is designed all from the committee, and the major driving for conformance test is from Google. And there's also tools, a set of tools available, like Shader-C, GL, GL Slang. All those tools are available. They are on GitHub. And last but not least is the validation layers. Validation layers is designed by Google. Is developed by Luna G, and Luna G, that portion is acquired by Google. So it's part of the Google's support. So we're going to talk a lot about validation layers later on. And the broad OS support, we touched on that. And the Mac OS is not, Mac OS, iOS is not here, is because it's not natively supported. Use the plugin, the wrapper, it will work. If you go to YouTube, you'll find it. Okay, with all of these good things, how do we start with Vulkan development on Android? So there's a video, this one, I like to skip it so that we can save some time for later. Okay, so this is one of the colleagues, he put this one to Android. I'm gonna skip it, this. So to do Vulkan, we need a device, right? So emulator not supporting Vulkan yet, so you need a device to test out the Vulkan applications. So when Vulkan was released in May, this set of devices that are supported on Android. Now there are more. And you need the OS, of course, right? You need an Android N is the first OS baked in for Vulkan support. And then you need another set of tools. The Android Studio is the easiest for the development. How many of you are from the game engine company? Writing game engines. Oh. So normally game engine company, they have their own IDEs. Android Studio, download latest Android Studio, and Android Studio will download SDK for you, which that is easy, very important too. With SDK, with the OS, then all the the OS Android N, they all have the library all built in already, and you need once you go off to your own application, then you will need header files and the library. The lib stub is not a full library because it's dynamically linked, right? So library stub is all inside NDK from release 12 and up. Then Vulkan is pretty big API. So some samples already baked. You can look at those samples, and these would help to get ramp up to start. So this is a set of one file samples. Each sample just include one file, and in that file is try to illustrate how to use that one API. Each one is one important one. And this is how you use CMake, generate the Android Studio project for those samples. As if you get the, right now, if you get the source code from a repo, you don't have to do this. It's already everything is checked in for this from this repo. So you don't, this one you don't have to do it. And in that you can import the generated samples into Android Studio. That's that one of the UI look like how to import it. This give a kind of the walkthrough for the samples of all those basic samples. You see from create instance and enumerate device and all the major APIs you need to use to create one application, one simple application, by the way. So to draw a cube. Draw a cube, right? In graphics rendering stacks, normally people say, yeah, how do I do my first triangle? This is the way to do your first triangle. So to draw a cube is, couple of triangles. So then you have a next one is adding texture, you get a textured cube. So the recommendation is to, it would be, it's not, it's true, like it would be, you walk through this and to see what's going on there, then you get some feeling of it. It's recommended, but I don't think you're gonna follow that. Because genius never follow other people. That's why you guys are called genius, right? Okay, so with that, we get into the next one is tips for what we learned from partners and from ourselves when we along the way doing the Vulkan. So mostly from partners working with us. So from these, there are a lot of materials from here. So I'm gonna skip some of these. I will pick up three from them. The three I think is very personal. These three would be what I feel is important. So the first one, he does have a lot of materials in here. First one is the validation layers. You got to use that one. You view that one as a must-use tool, right? So what the validation layers does, remember on that, is to check all the possible errors from your application. So that gonna save you a lot of trouble. On Vulkan, by the way, if anything said is wrong, it's gonna crash your system. There's we said it before, it is explicit. Anything you use, you set it. If you don't set it, it's gonna take whatever garbage in there, right? And you can imagine that it's gonna crash because this one goes down really to the GPU, to the hardware. Right, it's very, very low level. I was amused the other team over here. They do the presentations. They have a lot of the prompt for the Angular the JS. Have a lot of prompt to choose from. Vulkan is going to the different way. They give you everything you can possibly have. The choice is all yours from yourself. Okay. So, yeah, validation layers is going to rescue for a lot of troubles. Okay. So it can we talk about that already. It's detect, report errors, and also point out performance issues. So far, I think the third one is important. I will let you read it. So the partners working with us, they all have good feedback for those for the Vulkan validation layers. It's like a must. Okay, validation layers is important. Where do I get it? So there are 3 places to get it. The slide over here, by the way, is different for a little bit different from a slide you're gonna get from the conference. I modify this portion a little bit. So the easiest one for you to use is from NDK. The validation layers is packed inside NDK from NDK 12 and above. Later on we'll open the computer to have a look. So it's in that directory. We have a pre-built layers already there. You can directly use it, or if you want to have some more hands on it, later on we can show you, we can show why. So it is, for example, it's a trace code, right? Those one you need to build layers to yourself together with your application, with that build at the same time, so the symbols would set up correctly for your IDE. So you can trace the code from your application into the validation layers. Okay. Now this one over here is the Chronos group is the source for the really real source for all the validation layers on the GitHub. So you see NDK have a copy we get normally when NDK release, during the release time we get a snapshot and put in for NDK do a build. And there are other places in his original file is Luna G samples, and those are all coming from the Chronos place. Okay, how do you build validation layers? Okay, so validation layers is built with NDK build. So from your NDK build is always there in R12. You can use Gradle experimental. How many of you guys hear about Gradle experimental? Okay, so I will skip some of that part. So in NDK 13 is NDK build only. I took out the Gradle experimental portion of it. So that one is, that with Android Studio 2.2 release, it support NDK build natively in IDE. So that's a save a lot of hassle. Okay, once you build, you will need to pack them into the APKs together with your application so they can be loaded during the runtime. So then that solves where it load from. Now, how do you enable validation layers in your application that is on your application source code-wise, right? You have this thing available in your APK, you already pushed down the target, then you're inside your application, how do you hook up to it, right? How to get it to track, to trace, to track your application. This is the way. For all the layers, put them into these instance layers. When you create instance, you give him the layer array name. Name is the only one that you use. Validation layer and the extensions all have a name. The name is a string. It's 8-bit character. It's not UTF-16. Okay, so you gave him the layers and the total count of layers. Then you go ahead and create instance. Then this will trigger for the loader to load it when you try to create instance. Yeah, you have that loaded. How do you use it, right? Because you loaded it. Yeah, then that's good. Then when validation layers find some errors, how do you want him to interact or tell you? This is the way you need to register for some mechanism over here. That this well-defined is the callback. You implement a callback function that defined like this. And you also need to register to the Vulkan to tell him, yes, I have a callback. I want to register it. Whenever there's any error, call my function. So we'll open the source code to have a look later. Okay, beyond the validations. So this portion here is the testing. It's trying to, many things, Vulkan is across all the platforms. Then on desktop, most new GPUs it's got to be from the beginning of the year or year before, from middle of last year. So those are new GPUs, and it's going to support Vulkan on desktop. You can. The easier thing is you go to a GPU vendor's place to check out. They will have, if they support Vulkan, they will tell you that these ones support Vulkan. Then you can use those platforms to validate your Vulkan code. So that if you feel on mobile development is a little bit too hard, too time consuming, you can do that. Use that platform. They use some other IDEs to validate the majority of your code. then it's only the portion that Android specific can be tested later on. So, okay, the second over here is the kind of a caution. Vulkan is still new. For standard to mature, it takes some time, and also the vendors also, new standard coming out, all people try to understand and gradually get to the same understanding. So this is new to everybody, right? So when it's new to everybody, then there can be different interpretations for this standard. So error can happen. So in early days, all kind of errors we saw during the beginning of the development. Yeah, so what is saying? Trying to be prepared and try, if you see some errors, report to the GPU owners and try to find a workaround for it to, so get yourself going. Distribute Vulkan. This is what I'm going to quickly go through. So with Vulkan, multiple APK, you guys hear about that? It's on Android, one application, you can have one APK, for one APK target for all the architecture, like ARM, x86, or MIPS if you want. All these things can be in one package. For that package can get too big when you get people to download to their phone. If they just use one, every phone is just one architecture. So if he download them, other libraries not used, is wasting his bandwidth for data. So the solution, there is a solution for that, is you split those APKs into different, multiple APKs. So each one address each architecture. Though there are some other criteria you can do this thing too. The Vulkan is one of it. You can say that my application for this APK version, I need a Vulkan. Then if that when you download, when a user downloading from a Play Store, if that platform doesn't support Vulkan, it will not download that one, but download the other one. So there in the future there might be another fine granularity for this, is which version of Vulkan is needed for your application. So, a little bit in the future. I'm not supposed to talk about the future. Okay, display rotation this way is, theoretically it's simple. On Android graphics, if your application up is this way and you rendering that way, so if you want to see it, you can ask Android compositor to do the rotation. That need a bleeding, right? So need extra GPU power. Oh, okay. Okay, so we need to quickly go through this. With the Vulkan, you can do this thing with one matrix multiplication. You save a lot of stuff. Okay, you need to quickly go through this. Okay, so major thing, this I want to talk about this one. It's multipass is another feature. But GPU rendering on mobile is all tile-based. So what is the tile? What is direct rendering? I'll leave you guys to find out later. Okay. So what this trying to tell you here is with multipass is you have a multipass application. You build single rendering path, put all the paths into a subpath. So you give it to GPU with one submit, and it will do all the drawing for that bin at one time. So in that case, it's good. You don't have to bring memory back forth anymore. So save you a lot of waiting time. So that brings the processing power. Okay, so benefit those things.